Hi there. Today we're going to talk about Lesson 89. Lesson 89 deals with diagonals, interior and exterior angles. As a point of vocabulary, a diagonal is a line drawn from a vertex to a vertex inside a geometric figure, generally forms a triangle. Here's an example. Vertex to vertex forms two triangles. Okay, divides that rectangle into two triangles. Now there's exterior angles and interior angles. The interior angles are angles that open into the interior of a figure. For instance, this angle and this one and this one and this one. Okay? And here's another example. Interior angles. This is a 1, 2, 3, 4, 5, 6-sided figure. And the interior angles are marked in red. Okay? These are the angles that open to the inside of the figure. Okay? Notice I've drawn some diagonals in here, which forms actually 4 triangles inside of that hexagon. Okay? Now, to find the measure of the angles, we have to draw in the diagonals, which I've already shown. And then we have to find out how many triangles we can draw in there. So when I drew in from here to here, here to here, here to here, I made 1, 2, 3, 4 triangles. Each triangle has 180 degrees. So if I multiply 180 degrees times 4, that's going to tell me that there's 720 degrees inside this figure. That's 1, 2, 3, 4 triangles times 180. Then you take that number, 720, and you divide by the number of vertexes or angles that are in the figure. 1, 2, 3, 4, 5, 6. When you do that, you get 120. So each one of these angles that opens to the inside of the figure here is 120 degrees. Okay? So we're going to do a little bit more practice with that so you kind of get a handle on it. It's not that hard, just a matter of kind of understanding it. Okay, so let's just look at something simple. All these examples need to go in your notes. This happens to be a square. All corners are right angles. There's 4 angles with 90 degrees on the inside. You can see that. Okay, so that makes 360. And 2 triangles with 180, that also makes 360. So that makes that pretty easy. If you take 360 divided by the 4 vertexes, you get 90. Now in this case, we can talk a little bit about the exterior angles. The exterior angles are the angles that when you draw straight out, you get 180 degrees. So that is this angle here. You draw straight out, you get 180. This angle here, you draw straight out, you get 180. Now, what we need to know is what's the difference between the interior and the exterior angle. What's the difference between the interior angle? Take 180 minus that and you'll find this exterior angle. Now that's pretty easy on this square because these are 90, so the other one's 90 each. So that's not too tough. Now you get something that's a little more complicated like this drawing, which is a tad more complicated. This is an 8-sided figure. 1, 2, 3, 4, 5, 6, 7, 8. Okay. When you draw on your diagonals from here to here, 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 you end up with 6 figures on the inside. If you count your vertices, you have 1, 2, 3, 4, 5, 6, 7, 8 vertices. So that also tells you that you have 8 angles on the inside to deal with. Okay? So the angles on the inside, these angles from here to here, these are all interior angles. Okay? From here to here, 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 here to here. Those are all interior angles. Okay? There's 8 vertices and there's 1, 2, 3, 4, 5, 6 triangles. 6 times 180 is 1080. There are 6 vertices, or excuse me, 8 vertices, I'm sorry. If you take 1080 and you divide that by 8, you get 135. Total degrees divided by the number of vertices will give you the degree measure of the interior angles. So each inside angle is 135. Now if we just look at one exterior angle, this is the exterior angle right here. If this is 135, then 180 minus 135 is Yep, 45. So the exterior angles are all 45 degrees. And that's consistent all the way around, because to do this you have to have regular polygons, which is very well proved by looking at this one. I drew, right here, I drew a trapezoid. Okay, basically. I went ahead and put in a transversal here, a diagonal. But if you look at that, can you see, sorry, if you look at that, can you see that the two triangles are not equal? No, they're not equal at all. They both have 180 degrees, so therefore the inside degrees of this thing is 360. But all the angles are equal on the inside? No, because you can see this one might be a 90 degree, but is this 90 degree and this one 90 degree? Is that 90 degree? No. Okay. So we cannot do the same thing with this figure that we did with the others, because it is not a regular polygon. It does not have regular measure. If we took 360 and got 4 and we got 90, we could not say that all these angles are 90, and therefore there's no way we could find the exterior angles. So if we don't have a regular polygon, put this in your notes too, if we don't have a regular polygon, this method does not work. Okay, so you'll be using this method with regular polygons, 4-sided, 5-sided, 6-sided, 7-sided, 8-sided, all with angles the same length, or excuse me, angles the same measure, sides the same length. Alrighty, I hope that was helpful. Have an awesome day.